Okay, so this is mine and Ruth's final project. So for our project, we chose the topic of identifying bird calls using Fourier transforms. So like I said, our goal is to use Fourier transforms to identify and classify the calls of birds common to Arizona. So we'll be looking at 3 specific ones in this presentation. So just a little bit of background. We used a couple different online databases to collect the baseline bird calls. So we looked at the Arizona Field Ornithologist Bird Sounds Library, as well as the Cornell Lab of Ornithology Macaulay Library. And the 3 birds that I mentioned that we'll be looking at are the verdin, the field sparrow, and the great-tailed gracken. And we found 2 similar projects that were done earlier. So the first one was completed by the Worcester Polytechnic Institute. So in 2010, 3 students created a handheld device that used a high-quality microphone as well as signal processing to identify bird calls in their area. They wanted to make the software more readily accessible to people via a handheld device, so more available for everyday people to use. And then the other project that we saw was done in 2009 by researchers at the Cornell Lab of Ornithology. Their project's goal was to create a bird identifying software using bird calls as well. So their research was used to create a bird identification software application called Merlin, which uses the lab's Macaulay library to identify more than 6,000 species of birds worldwide. So now we'll talk a little bit about the procedure that we did. So first off, using technology, in other words, more or less our phones, we collected wild bird call samples from our local area. And then considering we had an idea of what the birds were, we found sample bird calls from the digital libraries for us to compare them to. And then in MATLAB, we used a high-pass filter to remove low-frequency background noises from the sound bites to isolate the bird calls themselves. And then after that, we were able to visualize the bird's pressure waves, as well as use Fourier transforms to extract the dominant frequencies of the bird calls, and then compare their distributions with the samples that we collected from the sound libraries.
So our first bird, we first removed the background noise, which obviously for this particular bird was significant. And I'm going to play both the original soundbite and then the filtered soundbite. As you can hear, there's a lot of traffic noise and wind noise, and then the filtered soundbite. So this made it easier for us when we were looking at the frequency comparisons. So here are the pressure waves. On the left, we have our unidentified bird, and on the right, we have the verdin from the library. And I'm going to play the verdin from the library so that we can hear what that sounds like. So as we can hear, it sounds very similar to the soundbite that I previously played of our birds. And I just zoomed in a little bit here so we can see it looks very similar. Next, we're going to look at the dominant frequency and the distributions of the frequencies here. So we saw on this one on the left is our unidentified bird. The dominant frequency was about 5,216 hertz. And the verdin from the library was actually really close. The dominant frequency of that was 5,217 hertz. And we can see that the distributions are almost identical as well. So we decided that we had enough evidence to conclude that the first bird that we recorded was a verdin. And here's a nice picture. Our second bird, oh, that's a typo. Our second bird, we did the same thing. We removed the background noise. This one isn't quite as noisy in the background as the other one, but I'll play it anyway. There was quite a bit of traffic in that first one, so that just helped get rid of that background noise. So the pressure waves from our unidentified bird and the field sparrow from the library are very similar. The same kind of repetitive chirp going on there. And I'm gonna just play both of these to show that they sound similar too. And then we looked at the frequencies. Now this one was a little bit more difficult to positively identify. We can kind of see that it might be bimodal. We've got kind of a larger section here and then a larger section there. But on the library one, we can definitely see those two peaks in the frequency distribution. The dominant frequencies are a little bit different, but again, that's kind of expected with different individual birds, even with the same type of bird. So because it was a little bit more difficult, we actually did do a comparison to another library soundbite as well to see what that was like. And I'm going to just play it here. That same trilling kind of noise, and there's the ones that I've already shown you for comparison. And then here again we see that two peaks, this one right here and then this one here. So it's similar. Similar enough that we have tentatively concluded that this particular bird is a field sparrow. Our third bird, we removed the background noise again. And here's the library. Oh no, I'm sorry, the background noise. So we can see that background noise has been removed. That'll help us. And then here's the library one. There we go. So with this bird, the calls do sound different. The great-tailed grackle is a songbird, so it has a lot of different calls. We weren't able to find a call that sounded exactly the same as our call, but that didn't really matter for the distribution. So we see a really nice distribution here. It's got many peaks. It seems like there are perhaps 5 or 6 peaks that are very easy to identify, and they're similarly spaced as well. We see both distributions, if we're just looking at the left-hand side, both distributions are left skewed with those multiple peaks. So we decided that we had enough evidence that we concluded that this particular bird is a great-tailed grackle.
So just to kind of summarize our conclusions, so despite some slight discrepancies, primarily the sparrow, we still believe that we can conclude that this is a very effective way to identify bird calls. Overall, there are really clear matches between the library samples and our own recordings, and this leads us to believe that our procedure does a good job of isolating the calls, their pressure waves, and dominant frequencies, so we can compare and contrast accordingly. And similar to the projects that we mentioned in the background, we'd love to see these methods used on a larger scale for everyday people. Because while there are digital libraries available for people to identify birds on their own, sometimes it can be difficult to be sure of what you're hearing. Good example of that is the grackle. They sound similar, but it's hard to say if you're not an expert. But with this technology, we believe that even beginner bird watchers can learn so much more about the wildlife in their area.